Computers were supposed to send paper back to the Stone Age. No more letters, just emails. Goodbye typewritten reports. Hello floppy disks. Well, those predictions were wrong. Photocopiers and printers have us using more paper than ever before. Paper production begins with the arrival of wood at the mill. Paper is made from a paste produced from a mix of 65% maple, 25% birch, and 10% poplar. They require 2 tons of wood to produce 1 ton of paste. Everything starts from this debarking drum, which removes bark from the logs. It's about a 20-minute operation. The bark will be burned to produce steam for the operation of the mill. The debarked logs are transported on this conveyor. All is controlled by an operator. Now the logs are reduced into small pieces called kindling. They're accumulated into a pile and remain outdoors, winter and summer. The kindling looks like this. These 5 piles total about 30,000 tons of kindling. Next step, reduce the kindling into a paste. They begin by washing it. This screen verifies that the washer is properly loaded. Then comes alkaline cooking. This diagram controls its operation. This huge cylinder is the washer in which the kindling is cooked for several hours at a temperature of 315 degrees. And this is the recuperation boiler. It burns wood lignite at 1800 degrees. Certain chemical products which come out fused as lava are recuperated. This black liquor, a residue of burned wood, will be burned to produce steam. Exiting the washer, the brown paste is washed and sent to the thickener. With this spatula, they verify the quality of the brown paste washing. The paste must be bleached. This alkaline extraction tower places the brown paste in contact with chemical products. It's bleached with chlorine dioxide and gradually becomes more white. Then the water is partially drawn off. Water is extracted with this equipment, the Bellois Belbay 3 paper machine, operating at a speed of 3,500 feet a minute. Between the entry and the exit, the concentration of water in the paste falls from 95 to 5%. Here we see the sheet of paper coming out of the presses. Then, analyzers verify the quality parameters of the paper and signal any anomaly. The paper is then rolled up. This roller produces enormous main spools. With this transfer arm, they change a full spool for an empty one. A roll weighs over 35 tons and contains over 37 miles of paper. The spooler cuts the main spools into smaller, less wide rolls. Some will be delivered as is, while others will be shipped to paper cutters. Rolls are sent to an automated warehouse. In the warehouse, they store rolls that will be cut later. Robots guided on rails in the floor feed the Biolomatique paper cutter. This is the one that produces copy paper. Robots are controlled by a central computer directed by operators. Production reaches 55,000 sheets per minute. We see here the transfer section of the cutter. 4 automatic catchers and operators verify paper quality before packaging. In 1 hour, this mill produces 6,600 packages of copy paper. A single log allowed for the production of at least 15 of those packages.
Molded pulp isn't exactly a household word, but it is a household item. Chances are you've got an egg carton in your fridge that's made of it. This thick cardboard-like material can be shaped into a variety of containers, such as those drink carriers they give you at the fast food restaurants. Farms ship out their eggs in trays called filler flats. These flats begin as recycled paper. Old phone books, newspapers, magazines, cardboard, pretty well any product made of paper fibers. The factory even recycles its own flats that have been rejected by quality control. The raw materials go into what's called the pulper, a giant blender that mashes everything up and blends it with hot water that's 43 to 65 degrees Celsius. The hot water swells the fibers, causing them to break apart. After 20 minutes, they become pulp, a watery mixture roughly the consistency of hot oatmeal. The pulp exits out the bottom of the pulper through a filter that screens out plastics and other contaminants. Shaping the flats is a fully automated process. Formation molds descend into a vat filled with pulp. A vacuum sucks the mushy mixture onto them. Water jets rinse off the excess. Rotating above are transfer molds. They grab the flats off the formation molds and move them onto a conveyor. Before the transfer molds grab the flats, though, a brush applies a water-based lubricant. This ensures the flats won't stick to the molds. It's just like greasing a baking pan. The molds themselves are made of bronze, plastic, or aluminum, depending on how long the factory intends to use them. They're covered with a stainless steel mesh. This mesh ensures an even vacuum through the mold so that the pulp spreads over it evenly. The soggy flats now go into an oven for 12 minutes to dry out. The 205 degrees Celsius heat evaporates the water. This bonds the fibers together, forming a rigid material. After they exit the oven, a device appropriately called an upender flips them up so that they stack into each other. A built-in counting mechanism triggers the machine to section off the required number of flats per package, then compress them, and seal them in plastic film to keep the dust out. The factory uses the identical molding process to make 4-cup drink carriers. These too go into an oven to dry out the pulp, but only for 6 minutes, half the time the filler flats need, because this product is smaller and lighter. Automated compactors stack the finished drink carriers. Then workers compress them for packing and shipping. The factory also makes disposable urinal bottles for hospitals. They add chemicals to the pulp to make the bottles liquid tight. These molds are three-dimensional and lined with mesh on the inside. When they submerge into the pulp vat, a vacuum sucks in the pulp. When they resurface, water jets rinse the excess pulp off the bottlenecks, and the vacuum sucks out the water. A spiked conveyor belt transports the bottles to the drying oven. They dry at a lower temperature than the flats and drink carriers do, 176 degrees Celsius, and for a longer time, a half hour. This ensures the chemicals making the bottles liquid tight cure thoroughly. While urinal bottles can't be recycled for sanitary reasons, drink holders and filler flats are recyclable, making them extremely environmentally friendly.